In this video, we're going to talk about finding a transfer function from a block diagram. So block diagram is nothing but it is a pictorial representation of a control system. So whenever it comes to the control system, we always talk about open loop system, closed loop system. So open loop system is nothing but there is no feedback from the output. So you're just driving your car by closing your eyes. You're not giving any feedback to your mind or to your hands. Okay, that's an open loop system. Closed loop system is nothing but you're giving the feedback. Okay, so whenever you see open loop system, so here is the transfer function. So this represents the system. Y is the output, U is the input, H is a system. So this is an open loop system. When it comes to the closed loop system, see, there's feedback. The output is going to be part of output is going to be given it back to the input. Now, if you look into this simulation diagram here, okay, here this is called summing point, a point where we can add 2 or more signals together. Now here you can see this is either takeoff point or branch point. Okay, now whatever signal comes here, say some A is coming there, A is a signal. Okay, so at this takeoff point, that A signal is going to go through that, A signal is going to go over here too. That's the more important you need to know, important point you need to know. Okay, now next one. Okay, here is a closed loop system. So for the closed loop system, RS is the input, reference input, also called command. Y is the output, U is the input. I didn't show you anything here. Instead of R, sometimes we use input U. ES is the error signal, FS is the feedback signal, GS is the forward path transfer function, HS is the feedback transfer function. So this GS and HS, they are two independent systems, small systems. They are working together to perform an action. Okay, now here I have how do we combine these blocks and make it as a single block? So how do we combine these small individual blocks into single block? Now, so here is, it's an open loop system. YS, which is output, equal to GS times US. GS is the transfer function, US is the input. Now, if 2 of these blocks are in series, this is called series connection. Okay, in series connection, to get YS, so these 2 blocks, when the 2 blocks are in series, you just multiply them. Okay, so YS equal to multiply these 2 and multiply with input HS. Next one is parallel connection. So when they're in parallel, you're going to add them together. So YS equal to GS US plus GS US. So basically Y over U equal to G1 plus G2. That's what it is. I'm not showing you suffix S. I'm assuming it is in S domain. So when they're in parallel, it's just addition. When they're in series, it's just a multiplication. Now, feedback, negative feedback. So here, the feedback is a negative. So if you have negative feedback, the transfer function is nothing but GS over 1 plus GS. Here, the feedback is unity. There is no block here. If there is no block, we will take that as a unity feedback. Okay, how do we get this? So the signal here, I'm going to ignore S suffix S. So it's going to be G times E. Okay, G suffix S times E suffix S. I'm not writing that. So GE. Now, if I write what is the E here, this E equal to, I'm getting R as an input minus whatever the signal here, that is nothing but GE. Okay, so if I pull the GE to the other side, E times 1 plus G equal to R. Okay, so this is my input. Now what is my input? Y equal to basically G times E. So what is the transfer function? Y over R is nothing but E times Y equal to G times E over R is nothing but E times 1 plus G. So E get cancelled, Y over R is nothing but G over 1 plus G. So that's what you will end up with. So I highly recommend you to remember this. Do not solve every time for this. Okay, whenever you have negative feedback, remember, if you have negative feedback, you will end up with positive there. If you have positive there, negative here. Okay, another one here. I have a feedback block H of S. So if I have a feedback block H of S, then the transfer function is going to be Y over R equal to G over 1 plus G times H. Okay, that's the transfer function. We're going to use this a lot, so I need you to remember or practice these two a lot. Now here is the first example. Obtain the transfer function from the given block diagram. So there are so many individual blocks. We're going to combine them together, make it as a single big block. Okay, so here the first thing is we can see we have feedback Z2 and H3 and Z3 and H2. I don't know why I put that in the reverse direction, but that's okay. So here you can see from this Z3H2, from this block Z3H2, I can write this as C. If you have negative there, it's going to be positive in the middle. Z3 over 1 plus H2 Z3. Same thing the other one, Z2 over 1 plus H2 Z2. Now if you remember, these three are in series. If they are in series, what can we do? We can multiply those three. So that's what I did. I multiplied all three. So Z1 times Z2 times Z3 over 1 plus H3 Z2 plus times 1 plus H2 Z3. Now there is one more, a whole big feedback. So based on this, okay, so if I take this as X, so C over R is nothing but X over 1 plus X plus H1. So if I take this as X, C over R equal to X over 1 plus H times X. Okay, so if you substitute X value in there, we'll end up with C over R equal to Z1 Z2 Z3 over 1 plus H3 Z2 1 plus H2 Z3 plus H1 Z1 Z2 Z3. That's the transfer function. I will solve the next example. I thought of solving next video, but I'll go ahead and solve in this video. So here is the question: obtain the transfer function for the block diagram. Okay, so we need to, as I said, we need to combine these blocks and minimize number of blocks, make it as a single block. That's our final goal. Okay, see, are there any feedback or feedback in this blocks? Give me a sec. I'll stop this video here. I will solve this example in the next video. Thank you.